The James Webb Space Telescope is revealing the universe in an uncommon way, showing us genuinely stunning occasions. This telescope has been instrumental in reforming our comprehension of the universe, giving us the capacity to investigate the profundities of the universe. As of late, it has made a genuinely astounding revelation. It has recognized 700 worlds caught in a dark opening, counting Stephan's quintet, a gathering of 5 collaborating worlds. We will dive more profound into the revelation and how it influences both us and our origination of the universe. How the situation is playing out here is the compound mark of water fume. The James Webb Space Telescope is furnished with a variety of cutting-edge logical instruments, cautiously intended to notice the universe at an extraordinary scope of frequencies. With a primary mirror more than 6.5 m in measurement, this telescope surpasses in size its predecessor, the Hubble Space Telescope. This permits the JWST to gather and shine light from heavenly objects with unparalleled accuracy and responsiveness. Instruments incorporate a strong close-to-infrared camera, a mid-infrared spectrograph, and a stepless spectrograph. These instruments cooperate to catch pictures, measure spectra, and study the properties of particles going from the most seasoned universes to the planets of our nearby planet group. One of the marvels we can find in the universe are dark openings, grandiose entities that begin from the gravitational breakdown of enormous stars. At the point when a star depletes its atomic fuel, it encounters a calamity known as a supernova. During this interaction, the external layers of the star are catapulted into space, abandoning a thick center. If the mass of this center surpasses a certain critical limit, around 3 times the mass of our Sun, the gravitational forces become so serious that they cause a much more articulated breakdown, bringing about a peculiarity at the middle. A peculiarity is a place of endless thickness and gravity which can't be noticed straightforwardly. However, the James Webb Space Telescope has the capacity to see past what some other innovation has yet accomplished. One of the most astonishing revelations made by this telescope is the presence of 700 universes inside a dark opening. This finding difficulties the customary comprehension of how dark openings work. A critical trait of a dark opening is its occasion skyline, an imperceptible limit beyond which getaway becomes unthinkable, even for light. This limit marks the place where the gravitational draw of the dark opening turns out to be so extreme that not even photons, the quickest particles in the universe, can cross it. Any particle or radiation that passes this boundary is inevitably pulled toward the peculiarity at the core of the dark opening, a goal of no return. Most astonishing of all, the limit gravitational fascination close to a dark opening gives rise to a peculiarity known as time expansion. As particles approach the occasion skyline of a dark opening, time seems to elapse more gradually, contrasted with eyewitnesses farther away. This peculiarity, anticipated by Einstein's hypothesis of relativity, is expected to the distorting of spacetime brought about by the extraordinary mass of the dark opening. The occasion skyline is definitely not a strong physical surface like the exterior of a divine object, however, addresses a numerical limit beyond which the construction of spacetime acts in such a way that resists our instinct. The presence of an occasion makes a skyline around dark openings. Their immediate review is troublesome, yet this doesn't imply that it is totally incomprehensible. Their effect on the encompassing space can be identified through impacts, for example gravitational lensing, which is a contortion of light brought about by the colossal gravity of the dark opening. Gravitational lensing is a peculiarity anticipated by Albert Einstein's hypothesis of general relativity. At the point when huge items like dark openings twist the texture of spacetime around them, light from far-off objects passing close to these enormous bodies encounters a bowing in its way. This outcomes in a visual bending or amplification of the particle's picture. Gravitational lensing has turned into a critical device for stargazers in concentrating on not just dark openings, yet in addition other enormous heavenly objects. For dark openings, this impact is especially articulated due to their tremendous gravitational force. When a dark opening goes about as a gravitational focal point, it can make different pictures of a solitary far-off item or even structure a total ring of light around itself known as an Einstein ring. These peculiarities offer circuitous proof of dark openings and permit analysts to induce their properties like mass and twist, which are generally difficult to gauge straightforwardly. The idea of gravitational lensing reaches out past dark openings and incorporates other monstrous divine bodies like worlds and groups of cosmic systems. These bigger designs can likewise twist light, making bends and numerous pictures of articles situated behind them. From our perspective on Earth, this property of enormous items has been utilized to plan the conveyance of dull matter in the universe. Dull matter, which doesn't radiate or retain light, can't be noticed straightforwardly. However, its presence can be derived from the gravitational lensing impacts it actuates. By examining the mutilated light from far-off universes, cosmologists can make nitty-gritty guides of dark matter, giving bits of knowledge into the construction and advancement of the universe. One of the most famous instances of gravitational lensing is the Einstein cross, where a solitary quasar shows up as four particular pictures encompassing a forefront cosmic system. This peculiarity happens since the light from the quasar, found billions of light-years away, is bowed by the gravitational field of the cosmic system position between the quasar and Earth. The perception of such occasions not just affirms the forecasts of general relativity, yet in addition gives significant information on the circulation of mass in the lensing world. These perceptions help researchers grasp the idea of dull matter and the general mass dissemination in the universe. Moreover, to planning dull matter, gravitational lensing has been utilized to find exoplanets. When a star passes in front of one more star from our perspective, the forefront star can go about as a focal point, amplifying the light from the background star. If a planet circles the forefront star, it can make a transitory extra amplification known as a microlensing occasion. These occasions have been utilized to distinguish exoplanets that are generally excessively far off or faint to be noticed straightforwardly. Gravitational lensing likewise plays a pivotal job in concentrating on the extension of the universe. By analyzing the light from distant supernovae and worlds that have been lensed by interceding monstrous items, stargazers can gauge the pace of development of the universe. This technique gives a free beware of the qualities acquired from other methods, for example, perceptions of the grandiose microwave foundation radiation and the appropriation of universes. The investigation of gravitational lensing isn't restricted to apparent light. Stargazers have likewise noticed lensing impacts in different pieces of the electromagnetic range like radio waves and X-beams. For example, radio telescopes have identified gravitational lensing of far-off radio sources, giving extra information on the mass and design of lensing objects. Similarly, X-beam perceptions of universe groups have uncovered lensing impacts that assist us to guide the appropriation of hot gas and dull matter inside these groups. These multi-frequency perceptions are critical for getting an extensive image of the universe and the different peculiarities that shape it. High-level telescopes like the James Webb Space Telescope, JWST, are ready to improve our comprehension of gravitational lensing much further. With its strong instruments and capacity to see in the infrared range, JWST will be capable to recognize lensing impacts that are past the compass of current telescopes. This will permit space experts to study much more far-off and faint objects, revealing insight into the early universe and the arrangement of the primary systems. JWST's commitments to gravitational lensing research are supposed to give extraordinary bits of knowledge into the nature of dark matter, the circulation of mass in the universe, and the basic regulations of physical science. Gravitational lensing is an amazing asset that has altered how we might interpret the universe by permitting us to concentrate on the impacts of gigantic items on the light from far-off sources. It gives significant data on the mass arrangement and circulation of these items, from planning dark matter to finding exoplanets and estimating the development of the universe. Gravitational lensing keeps on being at the front of cosmic exploration. With the coming of new telescopes and advancements, the investigation of gravitational lensing guarantees to reveal considerably more privileged insights of the universe, facilitating our insight into the universe and its hidden standards. Monstrous bodies like stars or dark openings are particularly viable in causing huge gravitational lensing due to their enormous gravitational fascination. Dark openings specifically represent perhaps the most outrageous models due to their staggering mass and compact size, prompting very articulated lensing impacts. By the way, have you known about white openings? The idea of a white opening emerges from the numerical answers for Einstein's field conditions in the hypothesis of general relativity. These arrangements recommend the presence of areas in spacetime where matter and energy emerge in a way practically equivalent to how they are drawn to dark openings. The distinctive element of a white opening is that it just permits matter and energy to stream outward. Nothing can cross its occasion skyline from the outside to within, which separates it essentially from